Good morning. Say, today I apologize. My pen is the tip of it kind of broke. So my writing is going to be even worse than it already is. So kind of bear with me here. I'm going to try to see if I can find a new pen. But I'm happy my technology is working, that I don't have to start recording videos over and over and over again. So anyhow, kind of bear with me a little bit. Today we're going to learn how to graph. If we have it in standard form, if you remember yesterday, standard form was when we have our x's first, and then we have our y's, and then we have our units over here. And so it'd be something like 13. So I can have any number out here, 3x plus y equals 13, but our x's go first, then our y's, and then our units. And so if we can get it into that form, a lot of times it's really easy to graph some equations. So today we're going to do that. So we're going to be really focused on the x and the y intercepts, we call them. And then we're also really focused on word problems and what those x and y intercepts mean and how to describe those. So I already have the warm-ups done. So pause your video, do your warm-ups, and then restart your video when you have it, and let's see if we have the same answers. Alrighty, welcome back. So you can see what I mean about my pen, and this is actually pretty good. Ordered pairs is probably the answer they're looking for, a pair of numbers that can be used to locate a point on a coordinate plane. Number 2, I got a negative 13. Problem 3, I got 28.2. 4, I got x equals negative 8. And number 5, I got y equals negative 7. Okay, so today, we probably talked about this in junior high, but we're really going to focus on these two things today, the x and the y intercepts. Y-intercept means it just where does it cross the y-axis? Where does my line cross the y-axis? So my tip of my pen kind of bends here, so it kind of makes my writing really bad. My x-intercept is, where does the line cross the x-axis? Oof, that's bad. So if we're going across the x-axis, our coordinate's going to be something like a 3, 0. Meaning I go to the right 3, don't bother going up and down. If I'm doing my y-axis, I'm going to have something like a coordinates called 0, 6, let's say. That means don't go up or down, don't go right or left, but go up 6. And so we have a 0 in places here that makes it, that is the intercepts. All right. So here we got a problem here that's called a diver. So again, we want to pay attention to the labels. This diver explores the ocean floor at 120 feet below the surface, then ascends at a rate of 30 feet per minute. The graph shows the diver's elevation before sea level during below the sea level during the ascent. So if we look at time here, he's at a minus 120. We can have a minus 120 because here would be sea level, 0 feet. He's on the surface. And right now he's starting at 120 feet. He's creeping up here. And right here in 4 seconds, he will be, or I guess it's minutes, 4 minutes, he'll be at the top. So we kind of pay attention to both the axis labels here. In this case, it's time, and this is his elevation in feet. He's increasing as time's taking along. My x-intercept would be 4 minutes. This would be my x-axis. This is my y-axis, and so that means at the beginning of time, 0 minutes, he's at 120 feet below the surface. And so those are the two numbers that a lot of times on graphs we're really kind of interested in. So when we do this, I love it when they give me a graph because all I have to do is look where my coordinate is. And so we write it kind of like this, x-intercept. And then on the x-intercept, to get to that dot, I would go to the left 4, don't go up or down. For my y-intercept, I would say I'm at 0, so I'm looking for this dot, so I went to 0, and it looks like negative 3. So a couple things important. When you're doing your x-intercept, the number's in the x part, and the y is a 0. When we're doing the y-intercept, over here the number is in the y part of the coordinate, and the x is a 0. Also, coordinates always have parentheses and a comma in between. For some reason, kids get lazy at this point, and they'll just do like -40 like this. Well, that's -40, okay? You must have a comma, and you must have parentheses. That's what defines a coordinate when we're reading it. Now, what's cool about this is when they give it in standard form here, a lot of times what we can do is we can just do this equation here by mental math. So, for example, if I want to find the x-intercept, well, I'm going to do it here. I'm going to put a 0 in for my y here. So if I put a 0 in for my y, doesn't my y just go away? Because 0 times -2 is 0. So now what I have is my 3x equals 12. I can do that math problem probably mentally. I'm just going to divide both sides by 3, and I got x equals 4. So when I'm over here doing my labels, x-intercept, I put a 0 in for the y, so I'm going to put that on my coordinate. And I usually do that first so I know what I'm doing. So I put a 0 in for the y, I divided both sides by 3, and I got x is 4. Put a comma. Now if I'm doing my y-intercept, well, then I want to put a 0 in over here for my x. 0 times 3 is 0, so this guy goes away. So really my math problem now says -2y equals 12. If I was to solve that, I would just divide both sides by a 2, -2, and I got y equals -6. So on my y-axis, y-intercept, I have put a 0 in for my x, and my y is a -6. So then that would be really nice, easy for me to graph, and we're going to do that today. Okay? So then give yourself a shot at trying it. And then I have my answers on the next page. So pause your video, do those 3, and then let's see how you did. Okay, so a couple things I want to point out as I'm looking at these problems. Again, we want to try to do it mentally, because that's our whole purpose, is to graph accurately and quickly. So when you were doing these guys over here, I'm hoping that, first of all, I didn't put these answers right, did I? I didn't put them as a coordinate on this one. So let's see, my x-intercept was -10 and 0. And my x-intercept was 0, 6. Now I like it. Okay, so as I was saying is we want to kind of do it mentally. So what I do is I cover it up with my finger or my hand, and I say, okay, if I'm finding the x-intercept, I put a 0 in for the y. So that goes away. So then I have -3x equals 30. So I would divide both sides by a -3, and I can do that in my head, -10. And then I come over here and say, okay, well, let's find the y-intercept. I'll cover this up, and my math problem says 5y equals 30. Again, I would divide both sides by 5. I can do that in my head. And then 30 divided by 5 is 6. So we try to see if we can do some of these graphings with mental math, okay? We don't want to make a T-chart. We could, but again, that's a whole lot of work to make T-charts. I don't like T-charts. They do work all the time on all graphs, but they are a lot of work. All right, here we got this tram in Albuquerque, New Mexico. The distance is about 4,500 meters to the top. It's going up at, the speed is 300 meters per minute. The function is here. So we'll start looking at these functions as they give them to us, because here pretty soon we're going to have to write these. So right now they're modeling it for us, telling us, here's the deal. It's 4,500 minus 300x. Gives the distance of the tram in meters from the top of the peak after x minutes. So on my graph, I want to have on the x-axis minutes. Sometimes they're helping us out here a little bit. The graph this function and find its intercepts. And what do the intercepts represent? This is really kind of a big part of today. In a word problem, after I'm all done graphing, what do these mean? Okay, so here's x. That's my independent variable. It's called time. Okay, and then my y means after I do all the math, so this is really my y here, that's my dependent. You tell me how much time the tram has been moving, and we can probably predict where the tram is going to be. All right, so they did all the math for us. They said they put a 0 in for that. 0 times negative 300 is 4,500. There it is. They found the x-intercept. I'm sorry, the y-intercept there. Now, they kind of did this over here. I look for this other 0 over here. In 15 minutes, because this is the minutes column, the tram is going to be at 0 feet elevation. So that means it's at the bottom. So as I'm looking at this graph, I'm just looking at these two numbers right now. In 0 minutes, I'm at the top of the hill, and then 15 minutes later, I'm at the bottom. So kind of do some studying of your data here like this so we can kind of make sense out of it. Now, on graphs, here's our graph that we have. We have to kind of look at our highest number on the x-axis, and it's like 15. So first of all, we need to say time, label it, and this is time in minutes. So put the units. And this side over here is going to be elevation. My light just went off again, and my iPad here is going dim, 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 like the battery is going out. So I'm not sure why it does that about this time. Hang on for a second. I'm going to go turn my light on. I think my iPad's light sensitive because now it's bright again. Anyhow, interesting. So let's see where we're at. Time in minutes. Boy, that's a crummy handwriting. Now, I needed my x-axis to go to 15. And I need to use most of the graph here. So I'm thinking if we take and count by 2's down there, I think we'll be okay. So this is going to be my 0 here. So in other words, I'm counting by 1s, but I'm just going to list every other one. 4, 6, 8, 10, 12, 14, 16. So that used up most of my graph on that side. Now on my y-axis, I got 4,500 is my top number. So this is obviously 0 here. If I counted by 500s, 5, 10, 15, 20, 25, 30 isn't going to do it. If I counted by 1,000, 1, 2, 3, 4, well, that might not be too bad. Because I need 4,500. So let's do that. Let's count by thousands. So really I'm counting by 500s. I'm just going to list every other one. So this would be 2,000, 3,000, 4,000. Yeah, that's going to be okay because 45 would be right about here. 5,000. That's not too bad. Okay, so now what we can do is we can just graph our XY intercepts. So this one says my x is 0, so that coordinate would be written like this, 0, 4,500. That's my x-intercept, so I'm going to make a dot at 0, 4,500, which is right there. And then here's another one that I'm really interested in. That says 15, 0. So that's going to be like right over here. Now, we could plot these points in between, but I'm just going to go right for my line and do my very best. This is kind of not that easy. So there's a pretty good line. There would be my line. Now I don't want arrows on both ends because common sense would say, number one, you can't have 0 distance in time, or 0 time, negative. So it has to stop right here. And then my other kind of bright deduction here is right now the tram is at the 0 ground level, and we can't have a negative elevation unless we're in water. So think about that. We don't want dots on either end. Now we have to tell the reader here what my x and y intercepts mean. So we need to state that the x-intercept means in 15 minutes, we need units as well, 15 minutes, the tram is at the bottom. Now let's go to the y-intercept. The y-intercept means at 0 minutes, the tram is at 4,500. I think they are in meters if I'm not mistaken. Let's go back up to our problem and look. Yeah, meters. 4,500 meters. So that's how you kind of state it. Okay? It means it's at the top of the mountain. 4,500 meters. All right, so here's one for you to try. Now, as you graph this thing, first of all, they gave us the equation. So that's like nice of them to do that. But let's look at the problem. The store sells pens at $2. So if I buy 2 pens, I want to times $2 times 2. If I buy 3 pens, that'd be $6. So this is my pens. So there's my X is my pens, because we have to decipher this. And they sell notebooks for $3. So again, if I buy 2 notebooks, I want to times it by 3 and get 6. So this is my y-axis. Here is going to be my y-axis is going to be notebooks. So that helps me figure out my axes. Okay, so pens, notebooks. Now before you start, let's find our intercepts so we know what kind of a scale we'll have. So find the intercepts real quick. Find your x-intercept and then find your y-intercept. Do that real quick, see what you get. Did you get that your x-intercept is 30? So I put a 0 in for the y. So that makes this guy go away. I see 2x equals 60, and 60 divided by 2 would be 30. So 30, 0 is going to be one of my intercepts. Next, I'm going to put a 0 in for the x, and that goes away. So over here, I like to do that so I remember where the other number goes. So I put a 0 in for the x, and I get a 20. So my y-intercept is 0, 20. So now I can kind of plan out my paper here on my scale. I think we count by ones. Surely, no. We're going to have to probably count by twos. We needed to get to 30 on the x-intercept. So if I count by twos, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Yeah, we could probably count by twos down there and use the whole scale. So this would be 0 here. That would be, so really it's going to be 4, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and 24, 26, 28. I'm just helping people count here. 28, 29, 30, 32. That'll work. Because my x-intercept was 30, so that means it's going to be right here. And then I need to count by 20s here, so maybe if I did 5, 10, 15, 20 might work here. This would obviously be 0 here. And I need a 20 there. So now I can draw my line. Okay, so now we can start using this graph to make some kind of sense here. So the way that it works this graph, and this is what's very important, is if I said, okay, I want to buy 8 pens, well then I can come up to my graph to my line, and I can buy 15 notebooks and still have just plenty of money. I could come and buy 8 pens and buy this many notebooks. So anything that's underneath this line here would be a combination of pens and notebooks that I could buy. Now I can't do this. Again, interpreting graphs is like super important. I can't say let's buy 8 pens and then come up here and say, well, I'm going to buy 22 notebooks, because this dot is beyond that line there. So I can buy all kinds of combinations here, but I can also from this graph deduct what I cannot buy. Let's go back to our intercepts here means, because this is kind of sometimes a challenge. So I always like to start out with the x-intercept. So my x-intercept means, which is right here, that if I buy, I think it was 30 pens. So if you buy wrong kind of buy, 30 pens, you can't buy, God learn it, keep buying the wrong buy any notebooks. I can buy 0 notebooks because I spent all my money on the pens, okay? That's what that one means. Now if I come up here to my 0 on the x-axis 20, y-intercept means if I buy here it is again. I don't know what's with my head today. If I buy 0 pens, I can buy 20 notebooks. Okay? So that's what it means, but I can do all kinds of other things with the graph. I could buy 20 pens here and this many notebooks, or I could buy 20 pens and 5 notebooks, because again, they're all underneath that line there, okay? So again, interpreting graphs, not just getting a graph and saying, look, I did it. I mean, that's important, but we also want to make sure that we can interpret it. All right, there's my graph there that I did ahead of time. Now, last thing I think we need to do is now we just want to start graphing quickly on a graph here. And I think your graph paper is a little bit better than yesterday's, I'm sure. And so here's the deal. It's already in standard form. So again, what I do is I try to find my x first. So I'm going to say I make my coordinates here like this, x enter, and I'll start to abbreviate x-intercept. So I put a 0 in for the y, so that means this all goes away, and I have a problem that's called 2x equals 8. Now, do you agree I would divide both sides by 2? 8 divided by 2 is 4. So now I go to my y-intercept, and I put a 0 in for my x, so that all goes away. So now my math problem says negative 4y equals 8. I divide both sides by negative 4. Again, you can do that if you still need this, but I want to push you to kind of doing mental math. I got y equals negative 2. Okay, so my y-intercept is 0, negative 2 is right there. X-intercept is 0, 4, 4, 0. So go to the right 4, don't go up or down. And now we can draw our line. Now this one we want to have arrows on both ends. You draw it clear to the other side, much better than that one. But you have a ruler. See if I can get it a little bit better. Still doesn't like my graphing here. When I'm in class, I do it on the board with a marker and a yardstick so I can get it a little bit closer. But anyhow, obviously you draw your line with a ruler between the two, okay? Now over here, this is not in standard form, but it wouldn't take me very much to get it into standard form. I would just add a half x to both sides. Okay, so now my real formula in standard form would be 1/2 x plus 2/3 y equals 4. Now if I plugged in a 0 for my y, because I want to find my x-intercept. So to do that, I want to put a 0 in for my y. So we'll do this so that I can maybe erase it. If I do this, my y goes away, because 0 times 2/3 is that. Now to get my x by itself, rather than dividing it by a half, I want to multiply by 2/1. We learned that earlier this year. Because when we're dividing with fractions, we're going to flip and take the reciprocal anyhow. So over here, 2 times 4 is 8. I don't have 8 on my graph down there, do I? That's okay. Now let's see if I can erase that. Okay. So now on this one, I want to find my y-axis, but I want to come over here because I see my light just went off and it's dimming again, so I can hardly see my screen. So bear with me again. All right, and here we are. So now, really, if I put a 0 in for my x here, the x goes away. And so now over here, I want to do it over here where I can see my work. I have 2/3 y equals 4. So once again, I want to take the reciprocal, 3/2, and multiply. Over here, it becomes just a y. That's 12. 12 divided by 2 is 6. So my y-intercept is 6. So I put a 0 in for my x, and I got a 6 out. So now let's see if we can graph this. 8, 0. Boy, that's kind of off the graph a little bit. But we can do it. Okay, so when I come over to the 8, so there's 6, 5, 6, 7, 8. Normally we won't do this. And I got 0, 6. So just for today, that's kind of not a very good math problem to demonstrate, but we'll be okay. My graph will be something like this. Okay? All right, so now you got a couple to do. Oops, I already did mine. So give it a shot. Pause your video, and then come back and let's see if your answers match mine. All right, so here's what I got. My 3a there. Make sure you have the same problems that I do. Just doing some cutting and pasting. Yep, minus 3x, 4y, yep, 12. So my x-intercept was 4, 0. My y-intercept was 0, -3. Again, my line's as close as I can get there, so your line should look very similar to that. And then over here on this one, I got my x-intercept was 6, 0. And my y-intercept was 0, -2. Probably should have labeled them over there on that one. All right, so these are your math problems. I love it when they give me a graph. Now again, make sure on your practice sheet that you write it as a coordinate. Some kids just cheat a little bit and say, hey, my x-intercept is 2. No, your x-intercept is 2, 0. They are coordinates. So as you're recording, make sure you record it correctly. All right, with that said, this goes pretty quick. It's kind of the first day, so they all should be kind of nice whole numbers. Uh-oh. I have my answer there. Interesting. And I can't erase it. Don't look. All right. So, anyhow, do those problems real quick, and I'm not sure why my answer is on there. All right, so with that, tomorrow we're going to do some more of the graphing and using standard form to graph, and then it's the weekend. All right, we'll see you tomorrow. Oh, one more thing. The the answer sheet. I'm going to be another one where you possibly grade your paper. I haven't decided yet. It might be a Google form where you just kind of put your answers, in a Google form. I'm just going to try to find a paper. You'll figure it out. Just follow the directions on the Google form. All right.